I will talk about React and performance in a moment, but I just wanted to congratulate India on landing a thing on the moon today, this afternoon. I'm not sure there were any React code on that machine, but I'm sure a lot of software engineers was involved, and it's not an easy thing to do. So I think that's quite amazing. But what I really want to talk about is what I call reactive iteration. And let me just start this. So today I will talk about performance. One of the things that is easy to get right with React is to make sure that you show the right data. The way React works is being reactive on your state, and it will just automatically, if you change your state, it will automatically show the right data. So correctness is one of the, I think, key benefits that React provides. But that sometimes leads to not so nice performance because things will be re-rendered a lot. And I will talk about today a pattern that will help you create components with large amounts of data that can update without being slow. So I will show a design pattern that I have been using, and it will, let me say a little bit about myself. I am a software developer. I work as a freelancer doing JavaScript and Python development. I like to do testing, and a previous talk of mine was about testing, but I will not talk much about testing today. I currently work at a company called Invert Bio, where our customers are biotech companies. So we do data processing, data visualization for biotech companies, and we usually need to show charts with a lot of data, and users need to be able to edit things about those data. So there was an interest in how do we make components that scale well to large amounts of data. And I have slides here, but let me actually show it live. So I want to show an example of this problem that I want to talk about. So I'm using a charting library here that is called Recharts, and I'm showing a chart here with 4,000 points. This is a line chart. It doesn't really make a lot of sense when you see it like this, because when you show 4,000 points like this. But one of the things you can do is that you can zoom in, and then you can see just a subset of the chart. Now it makes much more sense. This is something the users would like to do. But guess what? When I'm doing zooming, when I use the zoom feature in this library, it actually repaints, it re-renders the entire component. So it's very laggy. You can see how slow it is to update just with 4,000 points. And this is just a very common example that you will see with components to handle large amounts of data, that as soon as you start having 4,000 rows in your table or 4,000 points in your chart, or if you have a map where you can edit streets or street names or something, and you have also 4,000 points on your map, then if it's not engineered correctly or with focus on performance, then it easily have this kind of slow laggard thing that is not really nice to use. But you can do something about it. So let me talk about that. Yeah, let me just say a little. So the idea is that if you do an operation on one element in a large collection, you want rendering to be taking not 4,000 times the amount of time it takes, but just be O of 1 instead of O of n. So it should be constant and not linear if you're not really changing more than a single item. That's the general idea. So this is a problem I'm going to talk about. And here I will just introduce the solution, and then I will go into more detail about how this solution works. So when you create a component for a large amount of data, and I'm going to use a table as an example here because you have all probably worked with table components, then the usual way to do it is to make a table component that takes in the data that you want. So it's usually a two-dimensional table, right, with with an array of rows, and each row is also either an array or an object with all the values in the columns. And you usually just pass the data in like an attribute on the table component. And that's what makes it slow, because if you make changes to the data, then the data object will necessarily be a new object, and the table component will have to re-render everything. And that means it will be slow if you have a lot of data. So the thing I want to introduce you to is a different pattern where you pass in not the data, but instead you pass in a hook. And it's you who should write this hook. So this is the use data is not a built-in hook. I'm not going to talk about how to build the use data hook. You will have to create the use data hook for every single application that you need. The idea is to use this pattern where you pass in a hook to provide the data instead of providing the data directly. So it's kind of like an indirection. Instead of giving the data to the table component, you give it a method that will provide that data when the table component needs it. And when you do it like that, you can make it work so that only data that has changed will cause re-renders of that single data item. And this is relevant for a lot of things. So this is very relevant for tables, for any kind of list, tree structure. If you have charts, like we showed with recharts, and with maps, etc. And if we're talking about DFDS, for example, I'm sure that some of your applications have maps where you can see where containers or trucks or ships are currently located in the world. And they probably move around, have some kind of live feed that provides updated positions. So data will have to change. And maybe you will actually want that to be fast, so it doesn't like have to re-render the entire map every time a single ship changes position. That could be an example. And I will use Redux as in the code that I use for demoing, but this can work with any other reactive state management solution that you might happen to use. So if you don't use Redux, this still applies, even though I will use Redux in the example. All right. So let me do another demo thing up and running. So in this example, I have a table component, and I can scroll down. I think there are 2,000 items in this table. And let me also attach the React dev tools so that and you can see that I have added this, maybe you can't read it, but I highlight updates when the components render so we can see what is being re-rendered while we do this. And this is just a table with a number of things and a counter for each thing. So what I can do here is I can click on a thing and then it will increase. It's really simple code. It's much easier to demonstrate it with simple code. But as you can see, I can very quickly just increment the counter here on a single row, and you can see on the highlights that it doesn't render all the other rows. It just renders that single row. And that makes it fast, so it's easy to use for the user. And if you code it the simplest possible way, which is just not using a table component at all, but just writing the code for writing a table, and it will look a little bit like this. And maybe I should have had a pointer. Maybe I can use my mouse. I can use my mouse. So in this code, I use the Redux use selector, which provides the reactive state management thing, and I render a table, and then I loop over all the IDs in the data and render a product row with that ID. And then the product row will also call use selector to select just that row from the data. So here we select state.stock with ID and pick out the quantity and the name. And then we render the table row with a name and the button here. And the button where we show the quantity, and there's an onClick handler that will dispatch into Redux and increment action so that the state will update. So this is the code that runs this part of the demo. And this is actually fast. So what's the problem? We can go home now, right? Cool. End of talk. But the problem, of course, is that you want to have an application with 20 different tables all around your application, and you want them all to look and behave in the same way. You don't want to have duplicated code that inlines all the table logic all over the place. So usually you would like to have some kind of reusable component. And when we do this with the standard way here, you will see, and I can just switch over here in my demo to the slow version, and you can see it's working off the same data. But now when I click, it's actually slow because it has to re-render all the rows, and I can click a couple of times. I clicked 3 times now, but you can see that it's very slow to update here. This is just horrible, right? No users would like to work with something like this. And this is what you do if you code it in a naive way. And just quickly go over it. What we do here is we return the table and we just pass in the rows, and the rows are all the values in the list of products, the stock here. And because it's a generic component, we also have to pass in a definition of the tables. I'm not going to go into that, but it's basically returning the same thing as we did before. But this scales horribly. I mean, this works nice, and many table components that you can find on GitHub is working like this, and it works fine for 20 or 50 or 100 rows. And many tables just say that you should implement paging so that you can, because then they don't have performance problems. If you only show 20 rows per page, then it's never going to become a performance problem. But then you can't print the list, or you can't use built-in find on the browser to find the row you're looking for, or other kinds of features that might be nice to do when you're working with large amounts of data. So I want to show you how you can do this better. So let's go back to the demo here and click on the fast version. And maybe it's not that surprising, but let's see how it goes. So this is actually fast. And let's look at the code for doing that. And now we're going to go into a little bit more detail about how it works. So the product table is like before, where we select the IDs only, and we use the same column definition as we used in the other table. But instead of passing in the rows, we pass in this hook called useRow. And this is a hook that I have written up here, which is specific to my data structure and my logic. So I call this hook useProduct, and it takes an ID and it uses a Redux useSelector to just select that ID from the stock. So this is just basically extracting a piece of code from the first example, but turning it into a hook, and then passing the name of that hook or a reference to that hook. Remember, a hook is just a function, so we're just passing in a function to the table component. And how do we then implement a table component? We do basically the same as before. So render a table and loop over all the rows, and render a table row for each of them, deliberately passing the useRow hook into the table row. And since this is a hook, and since this is called something with use, so React treats this as a hook, I can call it here even though it's not a specific hook, but a hook that we have received as a parameter. So I'm allowed to call this hook here to get the row with this specific row ID. And then I can just render the table row, loop through the columns, and render each of the columns, get the value by using this cell thing. So it's basically just a mix of the first two implementations you saw, where the first implementation have this structure, and basically this useSelector, instead of being hard-coded inside product row, we have extracted that hook into something that I pass in. So it becomes part of the parameterization of the table component. And you can do that with all the other components that you need to write that handles large amount of data, and they will perform much better. That's basically it. I got interested in this because at Invert we work with large amounts of bioprocess data. So let me tell you a little bit about what Invert does. So the company works with biotech companies who use fermentation, which is a chemical process to create all kinds of molecules, typically from yeast or from other organisms. And you do that in big fermentation tanks, just like when you create alcohol, but you can create all kinds of molecules. And it usually takes 14 days or 10 days or something, or the fermentation itself. And you get a lot of data if you have automated sensors on your fermentation tanks. You'll get a lot of data. So you typically get thousands or 4,000 or 16,000 data points per metric that you're trying to measure. And usually you measure maybe 20 or 50 different metrics during a fermentation run. So you measure the amount of sugar, the amount of oxygen, or how much it bubbles, how much it grows, all these kind of things. So you get a quite big amount of data, and then you run various experiments. So you have different strains of the genes. So you run experiments on this strain and this strain and this strain, and then you want to compare them. So you want to create these charts where you compare things, and then you want to create little annotations. So you want to click and say, okay, this spike is really weird. I want to add an annotation there. So users want to make their charts editable or collaborative. They want to do something with them. So that was my motivation for looking into how can we do this efficiently. So you can find the code for this on GitHub, the demo code that I showed. And I also wrote a blog post about this, so you can read more about a little bit more going into the details. And that's basically it. And I hope that we have time for questions.
Anyone has any questions?
I'm sorry, it's not really a question. I just want to say that was really eye-opening, and I have never. I have thought about coding like that, but not quite in that way. You rock my world.
More questions? Christian?
So React hooks are supposed to always be called in the same order and not conditionally and all of those things. Do you, I mean, this obviously works. I guess you've worked with it enough but there are never any problems in that regard, or is the linter happy with it and so on?
Those are great questions. And you could, maybe I had showed my slides to you before, but I actually have a slide on this. Is this even legal? Are you allowed to do this at home? And yes, this pattern actually follows all the rules of hooks, and the linter does not protest about it. So the hook we're talking about is only called at the top level of the function component. That's one of the rules. So it's only called here, which is at the top level. It's not called inside any condition or loop, because the table row is inside a loop over here, but the hook itself is top level and it's not inside a loop. So yes, it's totally fine to call it. And it's not called after a conditional return statement. That is obviously true. It's the first statement. It's not called from an event handler either. It's not called from a class component. It's not called from inside a function passed to use memo, use reducer, or use effect. So, and it is always called in the same order because you always have the same number of rows. We can talk more about if you want to do add and delete the deletions of rows like that. That complicates the situation a little bit. But assuming you don't have that, then this hook is always called in the exact same order. So yes, this is, and I've been doing this on, not just on this project, but also on a previous project in production for quite a bit of time, or more than a year. But yes, it's a very unusual technique. I haven't seen it elsewhere. It seems very simple. It works really well. Other questions?
Sorry, I must have missed it because going in and out. But why does it have to be passed as a prop? You had in the previous slide that you just had on. In the top left corner, I see you passing it as a prop to use row. Couldn't you just import the use product directly? Oh, because it's a generic table row. No, never mind.
Exactly. It's a generic table, so different tables will need to pass in different hooks. Exactly. Yes. And that's basically the trick here. Yeah. Other questions? Can I reply to a question that has not been asked? Just a very quick one. So I do like testing, right? So a question about re-rendering, how do you unit test that? How do you verify that your performance stays good, that you don't accidentally add code that means that suddenly your table becomes very slow? And I don't want to go through this, but I just want to say that that's included in my GitHub code. How do you unit test this kind of thing so that you can verify and assert that actually only that single row that is changed is that row that is being rendered? Yes, you can do that. Thank you so much.